Alright guys, so my recording for 8.1 and 8.2 from the Accelerated 7 math class ended at the end of the macaw and the toucan problem. So please make sure that you watch the beginning of these notes to understand that bagel problem. There's also a video posted from last year's class. The audio is just a little bit quiet, so I figured I would record this and try to make an abbreviated version so you guys have a little bit more time to work on your practice. But people are going to be coming to school soon, so I'm in a rush. So I'm going to move kind of quick. Please raise your hand, ask Mr. Hall, our substitute, assuming it's still him, if you have any questions as we go. So this got it. Go ahead and try this on your own if you haven't yet. It says a zookeeper takes care of 5 mountain lions. And the zookeeper orders 32.5 pounds of meat for them each day. So we know that the 5 mountain lions, I'm just going to say M for meat or mountain lions or whatever you want to say, they consume 32.5 pounds of food each day. So each mountain lion receives the same exact amount. So this M is going to be the amount of food each mountain lion receives. What equation could you use to find how much meat each mountain lion eats? So 5 mountain lions consume 32.5 pounds. I want to isolate my variable of M, so I go ahead and I divide by 5 on both sides because M is attached to 5 through multiplication. So when I do that division on both sides, 30 divided by 5 is going to give me 6, and another 2.5 is another half. So we get that M, or each mountain lion, is going to eat 6.5 pounds of food every day. And just for good measure, let's check that division, and we are correct, 6.5 pounds. Always ask yourself what's going on with the variable and how can I undo that? As we get into problems with a little bit more going on, we want to think through the process that we are doing the order of operations backwards. So how we solve these really is undoing addition subtraction first, undoing multiplication division. We kind of work our way up that ladder. So a photography student wants to buy a digital camera that costs $269.95. We have a nice setup down here. So go ahead and fill in your $269.95. We know that that is the cost. If you want to make a down payment of $100, then that is what you have right now to go ahead and put down, but you don't have enough to buy the whole thing. This would be called layaway, which we'll probably talk more about later. So she's going to split the rest of it into 5 equal monthly payments. So go ahead and try to fill in the rest of your equation here and see if you can figure out how we solve for what each of her monthly payments is going to be. Need a math person. All right, so we got our down payment here. They went ahead and helped you a lot with this setup. So we put our $100. Then our number of payments, we know we're going to make 5 payments, and that would really be determined by how much you want each payment to be. So this is a little bit backwards. Maybe the store told you you only had 5 payments to pay it off. But what we have for how we're going to get to our $269.95 is the original 100 and then the 5 monthly payments. The first thing we want to do is get rid of what you've already paid because we want to know what is left. How much do you still owe? So we take away this 100 from both of these, and that gives me $169.95 is equal to the 5 monthly payments that I have to make. Now that I have my 5 monthly payments isolated, I'm just going to divide by 5 on both sides. And that is kind of awkward just because this 95 cents. So when we divide that out, we get that each monthly payment is going to be $33.99. So essentially $34. But each month she'd owe that much more. And at the end of that, she would be able to then get her digital camera. So that's how it works when you don't have enough money to pay for something, but you have the partial amount of money. You can make what's called a down payment. This is like how people buy houses. You make a down payment, and then you make monthly payments working towards paying off that final balance. So check this out, and if you want, you can even draw a picture to help represent this. An orange grower ships oranges in boxes that weigh 10 kilograms each, and each orange weighs 0.2 of a kilogram. The total weight of a filled box is 50 kilograms. So I know that we've got a box plus some oranges. My oranges are going to be red this morning. And that is going to equal my 50 kilograms. Or I could have written total or whatever I want. So let's talk about what we know. We know the box weighs 10 kilograms. we know that each orange is 2/10 of a kilogram, but that would need to be multiplied. I'm going to go ahead and say n for the number of oranges, and that is going to get set equal to our 50. So then we want to start solving from here. So we're going to first isolate out the number of oranges times their weight by subtracting 10 from both sides, because if I dump out all the oranges and I throw the box away, all I have is the weight of the oranges. So after I've dumped out the oranges, thrown the box away, I have 40 kilograms left from the box, but that's going to be equal, the only reason I'm circling this is I'm going to shift to 2/10 n. So that then means 2/10 n is equal to 40. I need to get the n by itself. I want to divide by whatever's multiplied by it, so I divide by 2/10. Now here's what throws people off. When I divide by a number less than 1, my value gets larger. So 40 divided by 2/10 is actually like 40 times 5, and we get 200. Because this 2/10 is really a fifth, division by a fifth is really multiplication by a 5, and that would be 200 oranges. So if you threw all those oranges on the floor, like I said, it's probably pretty expensive. And we could also say that's a pretty large box. So try the got it on your own. Pause the video. Come back when you have a solution. 4-H, if you want to know what 4-H is, talk to Acadia. She's involved in 4-H. She raises chickens and dogs and bees, which is awesome. I think her Phoenix Fair might be based off that. But try this out on your own. Come back when you think you have your solution. All right, so as we approach this problem, we have a calf that weighs 125 pounds right now. It's going to gain 65 pounds per month. And we are going to sell that calf when it is 1,000 pounds. I lost my highlighter. When it weighs 1,000 pounds. So we have a weight right now. We have something that we're going to gain. And then we're going to have our total. So the first thing we do is get rid of our weight right now. We want to know how much weight do I need to gain, or does the cow need to gain? When we do that, we get 65 pounds per month is going to equal 875. Getting my numbers backwards there. So now we have 65 times however many months, because it's going to be 65 pounds every month. So we're going to divide by the 65. And that gives me a value for M that is 13.46. So if we round, it's about 13.5 months. I should move that so that you can actually see it. So what that really tells me is it needs to be over 13.5 months to be over 1,000 pounds. So if we wait 14 months or 15 months, anything like that is going to work. This would actually be a great problem to be set up as an inequality, which is our next chapter. Chapter 9 on solving those inequalities where things are not equal to begin with. So let's check out a couple more where everyone gets messed up, because taking the verbal situation into the numerical is where people get confused. So we're not actually going to solve these. We're just going to write them out and practice converting this into a numerical expression or equation. So 7 more than twice a number. So we have 7 more than what? Well, then twice a number. So we can start with twice a number and then add 7. That would be equal to our 17. The product, remember what product is? Product is the answer of a multiplication. So the product of 2 and a number, so really, again, we have twice a number, increased by 17. Oh, wait a minute. The product of 2 and what? The and is a number increased by 17. So this, actually, depending on how you say it, could be written 2 different ways. We're going to talk about this one in class because I really want to be here to talk about the emphasis between them. C, the difference. Think about what is a difference problem. That's subtraction. So between twice a number and 7, so we start with twice a number, and 7 is the difference, is 17. And our last one here, 17 less than. So the less than comes after something. So that's 17 taken away from. Well, taken away from what? Again, our twice a number. And that is 7. So write an equation for the got it to represent 8 less than 10 times a number is 36. Pause the video for a second if you need. 8 less than 10 times a number is 36. So I have 8 less than is going to come after something. After what? 10 times a number. So 10n is 36 gets set equal to 36. We could then solve this out. Let's go ahead and actually solve this out. We might as well. This hasn't been that long. So I'm going to shift this up just so I have a little bit of space. The first thing we do, get rid of any addition or subtraction. So we add the 8 to undo the subtraction. That gives me that 10 times a number must be 44. And when I divide by 10 to isolate my variable there, I get that n will be equal to, and I don't even know if you can see because my screen is probably blocking this, so we get n is equal to 4.4. So that would be our number in this situation. That is the end of 8.2 for solving equations using multiplication, division, and the two-step process. So at this point, please grab a laptop or a Chromebook if there's any available, but because of map testing, there might not be, and go ahead and dive into your practice work. Do not do 8.2 unless you are all the way finished with 8.1. So if you need to work on 8.1, that is your top priority. Thank you guys very much. Appreciate your hard work. I will see you tomorrow. We'll be doing an alternative activity because the holiday is coming up. So stay tuned for that, and have a great day.